All right, so this is day 7 in our notes, introducing some basic concepts in statistics. We're going to start with a little bit of review, but hopefully clarify a little bit about some things that you've worked with in the past. Okay? We're talking today about measures of central tendency. Okay? And the term really that we're dealing with today is the term average or averages. Okay? In a statistical sense, average really just means a measure of center or a measure of central tendency. Now, when you hear the word average, which of these do you typically think of?
Mean.
The mean, okay? That's kind of the common language for it, and we all get what we're saying. But understand in math, there's actually 3 different or 3 different averages, depending on how you define your center. Okay? How are we defining the center? Each of these different measures that you've worked with before measures the center in a little different way. Okay? Now, when you find the mean of a bunch of numbers, what do?
You add them all up and divide by how many there are.
Yeah, add them up. Okay? Add them all and divide by how many there are. Now, when you do that, you're actually finding the center as it refers, or as it relates to the distance. Okay? The center, distance, okay, or by distance. Now, you might say, well, what does that mean? Well, let's take a look at this. Let's say here is your mean, and you've got scores, different values that you added up to get that mean. All right? So you might have one score here, and one score over here, and one score down here. Okay? So you have this distance below the mean, you have this distance below the mean, you have this distance below the mean. Okay? But then you might have other values. You might have a value here. You might have a value here. You might actually have like 4 different values. Okay? You actually don't even have to have the same number on either side of the mean. Okay? The thing is, though, the mean will have an equal sum of the distances on either side. Okay? So let's say if this, here, let's blow this up so we can see better. If, let's say this one is, 2 units above the mean, and this one is 3, and this one is 3, and this one is 4, this one might have been 2 units below the mean, this one might have been 4, but this one might have been 6, okay, below the mean. So if we added these together, we have a distance of 12 that the scores below the mean are total away from the mean. The ones above the mean, though, are also a total of 12 units away from the mean. So the mean here is the middle in relation to distance. Everything is evenly spaced on either side of it. Okay? Does that make sense? Okay? So that's one measure of center. Okay? Now, how do we find the median? Do you guys remember how to find median?
You line them all up from smallest to greatest, and then you just I just mark off until you get to the center. Mark off one from each side until you get to the center. Okay,
good. So there, what you're talking about, you have to position them all from smallest to largest. Okay? Smallest to largest. And you want the one that's in the center by position. Okay? And you also realize that, if you have an even number of items, it may not be an actual score. You want the center by position, but if you have an even number, you're going to have to go between those two middle ones. All right? So, for example, if this is our median, it doesn't matter actually how many scores are, or how far the scores are away from these. Okay? I could have a score here, 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 and here. There's 5 scores. Okay? To the left of my median, I could have a score here, 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 all the way over here, and here. And that's still going to be the median, because I have 5 scores on the right side, and I also have 5 scores on the left side. Okay? So again, we're talking about a median, which is the center by position as they're placed in order. Okay? So, then we have our last one, the mode, okay? The mode, and it is possible to have more than one mode. You would call, if we had 2 different modes, you would call the data bimodal, okay? 2 modes. It's also possible not to have a mode. All right, we'll say that in a second. But what is the mode of our data?
The value that occurs the most.
Okay, the value that's repeated or occurs the most. Okay? So this is the value that occurs the most. Okay? Now, here, I'm using this term kind of loosely, all right? But just to kind of see the center. Here, we're talking almost like at the center by what we could call, popularity. Okay? The center by popularity. In other words, when something is popular, everyone wants to be like them, right? So this is the one that more of the scores are like. Let me fix that. Now this is not an official math definition, but it's something I think can kind of help us understand it a little better. The person who's popular, other people try to be like them. So, we've got the one score that the most other things are the same as. That's going to be our mode. Now, it is possible that you have 2 different scores with an equal number. All right? Like you could have 2 different scores that both occur 5 times. All right? And if that's the most of any of them, then they would both be the mode. All right? You could also not have a mode. All right? There is no mode. If all of the scores occur an equal number of times. Okay? So if all the scores occur an equal number of times. Now, what we call this in statistics is we call this what's known as a uniform distribution. All right, if you were to make a histogram of these, it would kind of just be flat. across the top, okay, because they all have the same number. All right, so let's take a little bit of, let's collect a little data here, and let's find each of these. And I'm going to assume that you know how to do these already in a basic sense. You've done them probably in a couple of different classes. But what I want to do with you is construct and use what's called a frequency table. Okay? So we have a score, and the number of times it occurs is its frequency. Okay? Frequency. All right? So, if you could, how many of you, we're going to go with how many brothers and sisters do you have? How many of you are the only child in your family? You have 0 brothers or sisters. 1, 2, 3, 4. Okay? So we've got 4 of you. How many of you have 1 brother or sister? 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. How many of you have 2 brothers or sisters? 1, 2, just 2? How about 3? No one has 3? I have 3. I have 3 brothers. How many of you, did I get everyone, or is there anyone left? Anyone have 4?
How many kids are here today?
Huh?
How many kids are here today? 15?
Well, that, well, counting me, 16 people. So, there we go. All right, so there's a total of 16 people here. All right? So there's our data. Now, let's consider how we would do this. And I'll kind of show you kind of the long way, but also then the kind of the shorter way of doing this if we use the frequency table. Okay? So first of all, we'll kind of go backwards because they're kind of easiest to more involved ones. So first of all, the mode. All right? What is the mode of this data?
1. Yeah.
1. There we go. And I was just going to say, one really common mistake is actually to put down the frequency as your mode. Okay? So be careful about that. The mode will always be one of your scores. Okay? It's the score that occurs most often, and that's 1 in this case. Alright? So 1 is our mode. Now we have the median. Okay? The median. Now we said this is the middle by position. Okay? When you have a frequency table, you actually still can figure out what the median is relatively easily. But let's look at how. Okay? If I were to arrange these in order, I'd have 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 2, and 3. Okay? So there's a total of 16 scores.
Median's 1.
The median is going to be 1. Now, if we have 16 scores, all right, that means half of 16 is 8, right? So here are 8 scores, okay? And here are 8 scores. So actually the median would fall between the 8th and the 9th score. Okay?
Don't you add them and divide?
Yes. You would find the mean of the 2 middle scores. So 1 plus 1 divided by 2 is still just 1. Okay? If they're the same, it's going to be what they are. Alright, but that's exactly right. When you have an even number of scores, like you do here for the median, you find the 2 middle ones, and you find the mean of those. Okay? If there were an odd number of scores, then there is just a score that's right in the middle that has an even number of scores on either side. Okay? Now, here's the deal. I don't have to write all those out. Thankfully, because if we did this for the whole high school and had, I don't know, 1,000 people's worth of, in the frequency, we'd have to write out all 1,000 and find the middle, right? We don't have to, because since there are 16 people, if we cut that in half, we get 8, all right? And that means the median is between, since it came out evenly, it's between the 8th and 9th score. Okay? So now, if you look at these, the first 4 are all zeros, and then the next 9 of them are all ones. Okay? So, we have a total of 13 now, right? 13 people have either 0 or 1. So obviously 8 and 9 are both in this 9 here. These 9 ones. Okay? And since that's the case, since they're both in there, they both must be 1s. So when I find the mean of them, it's going to be 1. Does that make sense? That's how you can use the frequency table to find your median rather than having to list them all out. Okay?
Mr. Kristen, I think it's time to go.
Oh, yeah.
And you don't have bells today.
What do we have?
Yeah, we end at 40.
Alright, so we've got like 20 seconds. So let me finish up mean real fast. Okay? Rather than adding all these up, okay, here's what we have with the mean. Alright? The mean is going to be the sum of each score times its frequency over the sum of the frequencies. Now, the sum of the frequencies we already said was 16. We saw there were 16 people. But rather than adding up 9 ones and 4 zeros and 2 2s and 1 3, we can simply do 0 times 4 plus 1 times 9 plus 2 times 2 plus 3 times 1. Okay?
Yeah, that does make sense.
We're multiplying
People times
Math.
the score 0 times how many people had that, plus the score 1 times the 9 people who had that. So we get 9 plus 4 plus 3, that's 16. Okay? So we end up with 16 over 16. So the mean number of siblings that you guys have is actually 1. Okay? Came out perfectly. Okay?
Thank you.
All right. We'll see you guys
Sorry.
Thursday. Have a great day.
What
Okay.
would happen if it was 20? You divide that by 2 is 10.
If there are 20 scores and we're trying to find the median, you divide by 2, it comes out evenly, so it's 10. So you would want 10 scores to be below the mean and 10 scores to be above the median. The median. So you would actually pick a score between the 10th and 11th, and you would find the mean of the 10th and the 11th score. Okay? So for example, in this case, there were 25 employees. So we're picking the 13th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 would be 33,450. Okay? That's our 13th score. That's the median. If, say there was another one up here like 500,000 or something, making 26 employees, then we would find the mean between the 13th and 14th score. Okay? Alright, so here you're interviewing for a job. The person interviewing you says that the mean wage is $60,849. That sounds pretty good, right? Okay? However, if you look at the actual data, the median is $33,450, And if you look at the mode, where's the mode here? Do any of these, does this have a mode?
Yeah. 12,000.
Oh yeah, here's our mode right here. Okay? So question, which of these numbers is most representative of the actual data, would you say?
Median? Probably, yeah.
Okay? Look at where our mean lies. Our mean would be somewhere in here, right? 60,849. So the median score does tend to represent our data a little bit better, because we've got some people who are really, really low. Okay, maybe they're part-timers or something like that. But then we got these guys up here that are really, really high. Okay, these are executives or whatever. Okay. Right here, though, you'll notice a lot of the different values, go from 20 to 48,000. Okay. So this is kind of right in the middle there. More of the data is close to our median than is close to the mean or, of course, the mode.
Okay, why'd you put mean there?
The mean was 60,849. So that's kind of where it would fall, would be right in there. Okay? Yeah, it would be between these. All right? So you're right, the median would be more representative of our data. Okay? So question, here's where we need to use statistics. And anytime we're using statistics, there's actually kind of a responsibility that we have to handle those statistics in a way that is honest, okay, in a way that's not misleading. All right, statistics is one branch of mathematics that people misuse a lot. All right, we're in a political season. You're seeing statistics misused all over the place by everybody. Okay, so what do you think about the interviewer? What's he trying to do by telling you that the mean is 60,849? Is he lying?
No.
No. But what do you think about this guy who's interviewing you?
Wait, what do you mean, who's he?
He's trying to make.
You're interviewing for a job.
Oh.
And the guy who's interviewing you tells you that the average annual income of all the employees in their company is $60,849.
He's trying to make it sound like you would be paid more. He's trying to make the company look better.
Okay, yeah, he's trying to make it look as though the company is really generous, has high salaries and whatnot. Okay? And if you look at the mean, that's true. All right? Yes?
Just I thought, isn't that worse for him? Because if you get the job and he gives you a below that salary, you're gonna be, well, everyone else makes 60,000. So
Well-
would you make him give you a bigger salary?
Well, but that's the thing. That's where you could then point to, well, this guy has the same amount of experience as you do, and he's making this much. Once you sign the contract or whatever, you're kind of stuck. But that's why you don't sign a contract till you know everything that's in it. But here he's trying to sell the position. He's trying to get somebody, and he might give you close to that, maybe, but that's not really an accurate representation of what's really going on, because you have these folks here that are making a ton of money, and they're pulling that mean up a lot higher. Okay? Now, let's say you are an employee here and you are trying to use these statistics to support your claim that they ought to pay us all more. All right, which statistic would you use?
Mean.
Hey,
To say that you wanted to get paid more? They'd say, hey, you guys are making an average of $60,000 bucks.
No, the mode.
Yeah, you'd probably, if you really wanted to misuse the statistics, you'd use the mode. Hey, the mode of our data, You know, our people are making on average $12,500. Well, that's not accurate either, all right? That is the mode, but that doesn't represent what's actually going on. And that's why when there are negotiations that break down, they call in an arbitrator, and the arbitrator would say, all right, both of you guys cut it out, and let's look at what's really going on. Let's look at the median. We got 33,000. How does that compare to the whole industry or something like that? Okay? So, we need to make sure that we're using, when we use statistics, we need to make sure we're using them in a way that's honest, that's forthright. We don't want to try to misuse statistics just to say what we want to say. Okay? Lots of people do that, but that's not how we're supposed to use statistics. Okay? All right.